Hey everybody, so it's Professor Miller, and somebody asked me about one of the reactions in lab, and I just wanted to go over it. It's a really good chance to review naming and writing reactions and balancing reactions, and then also applying our solubility rules we learned about. So this is really a review of exam 2. And then, after you've done that, you're going to ionize everything and figure out what reaction is actually occurring. All right, so naming first. The procedure gives us ammonium chloride and copper 2 sulfate. So I just copied that right from the procedure. And we break this down a piece at a time. So the word ammonium comes from the back of our periodic table. It's a polyatomic ion. Chloride, IDE, typically means that it's just an element with a negative charge. So chlor comes from chlorine. And it will have a -1 because that's what the periodic table tells us. And then we look at copper. Copper 2 means it's the copper with a +2 charge. And sulfate is another polyatomic from the back of the periodic table. So then we also want to make sure our charges add up to 0. That's what makes a compound legitimate. So +1 and -1 add up to 0. +2 and -2 also add up to 0. So these guys are all done. These are our reactants. Okay. You're going to want to take notes on this, like pause the video, write this down, because these aren't going to be around. We're not going to have a complete reaction written out on paper here, because I'm going to show you how they physically look. All right. So then your next step, well, the next thing I'm going to do anyway, is I'm going to think about the solubility rules, and I'm going to figure out whether these materials are going to be solid or aqueous. These are our only two options when you are talking about ionic things. Remember I told you that ionic things have really high melting points, so that means that they are not going to be liquids or gases. That just leaves aqueous or solid. A little hint for the reactions lab is that all of our materials for double displacement reactions are going to start out aqueous. Okay. But when you did that in the lab, you could see that it looked like water. It's not really water, it's water with stuff in it. All right, and so now we are left with ammonium chloride aqueous and copper sulfate aqueous, copper 2 sulfate. Okay, so this is our full situation with our reactants. Now, I just gave a big hint about the type of reaction this is, and the reason we need to know the type of reaction is because I cannot predict the products unless I know what it's going to do. This is 2 compounds, and specifically it's 2 ionic compounds. So the only kind of reaction we've studied that 2 ionic compounds can undergo is a double displacement. Double displacements are a lot like a square dance. So we're just going to switch partners, right? The 2 positively charged things, in this case I chose the cations to move, the 2 positively charged things just get moved. And now, with our new compounds, we need to balance the charge. So we can see that copper has a 2+ and chloride has a 1-. So that is not currently balanced. So we're going to need to put another chlorine onto that copper to make it add up to 0. We don't know if our product is solid or aqueous yet. We haven't got that part, so I'm going to remove my label there. Now over here, same situation, but it's too much negative charge now. So I'm going to add a positive to it, like that. Now, we don't write the chemical formulas this way. You wouldn't write NH4, NH4, SO4. That would be really tedious if we did. So what you actually want to write down is using subscripts to collect together the same type of particle. So one of our reactants is going to be ammonium sulfate, and the other one is going to be copper 2 chloride. We want to think about solubility, and as it turns out, ammonium is always soluble. So that one is an AQ. Doesn't matter what anion it's paired with, ammonium is always going to be an AQ. Chlorine is usually soluble unless you happen to put it with lead, mercury, or silver, which copper is none of those, so we're gonna keep that AQ label as well. Okay, so this is kind of like what you would write down for your products. Now, when we had to add another chloride and another ammonium, that can't come from nowhere. So in our original chemical reaction, we need to have 2 ammonium and 2 chloride, right? So if we go back to our original products, like so, like so. Okay, we have 1 particle of copper 2 sulfate, and we have 2 particles of ammonium chloride. That 2 needs to go in the front like that, right? And of course, we wouldn't write our charges. They canceled out and added 0. So really, you would just write 2 NH4Cl. That's the reactant for that, and there's still only 1 copper sulfate. And don't forget your AQs too. Okay, so that's our products. That's what our products are doing. Or I'm sorry, that's what our reactants are doing. Our products have no coefficients in front of them because we have 1 Cl and we have 1 ammonium sulfate. I'm sorry, yeah, that's right. Don't forget that we decided these are soluble. AQ, AQ. Now, we have a balanced, complete chemical reaction. Your next step is to break them all apart. Whenever something is ionic and aqueous, that means in water, it doesn't actually exist as 1 particle. It exists as a bunch of particles, and you can pretend like my table is the solvent, the water. So water surrounds each one. Water surrounds each one, but they're not actually attached to each other. They might kind of float around and be nearby each other, but they're not actually attached. They're free spirits. You can't tell them where to be. Same thing with this one, because this one was also ionic and aqueous. So if we were thinking about what our water looks like, this is a pretty good representation of it. Okay, just kind of random distribution. When we write the complete balanced reaction, we are showing the minimum ratio among all of these different components. But in reality, this is what the water would look like. Okay, water is the table, and all the cards represent our particles. Now, if we had a reaction that had a solid material in it, the solid or a gas even, or water, pure liquid, they don't break apart. They don't ionize. The only thing that ionizes is just ionic compounds that are soluble. All right? So insoluble ionic compounds, solids, pure liquids like water, or gases like carbon dioxide will stay together the way they were in your original reaction. Only ionic things are going to break up. Okay, so in a chemical formula, we would write these just by putting plus signs in between every single piece. And then you'll notice we have 2 NH4s still, and we have 2 Cl minuses. So we would write that like this. Okay, so we have 1 copper, 2 ammonium, 2 chloride, and 1 sulfate. You'll notice that those numbers are the same as what I started with in my complete balanced reaction. That should be true for all of the ionic equations.